Hello guys, welcome to my YouTube channel. So today we are going to solve another problem based on stack. Okay, so this problem is from Leetcode. I am going to share my screen. Okay, and I'm going to share everything one by one. Okay, so first of all, this is the problem 155 minimum stack. Okay, so here we are going to design a stack that support push, pop, top, and retrieve the minimum element in the constant time. Okay, so here first of all we need to initialize minimum stack. Okay, minimum stack class so already given by lead code. Okay, and I need to find, like, I need to push the element. Okay, so here push means we are going to add the element inside the stack by using push. Okay, and pop means remove the element, top element of the stack. Okay, so by using this function. Okay, and here get minimum, retrieve the minimum element from the stack. Okay, top means it will give you top element or last element from the stack. So we are going to write code for these function. Okay, so here you can see this is the input. This is like minimum stack push. Okay, so here this is the minimum stack empty. I'm going to push -2, 0, and -3. Okay, and get minimum. So here this is also empty. Pop is also empty. Top is also empty, and get minimum is also empty. So it will give you result null, 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 and -3 and 0 and -2. Okay, so we will see here inside this. Okay, so we have, this is our input. Okay, minimum stack push, get top, and get minimum. Okay, so here output should be null, 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 -3, null, 0, -2. Okay, so here I'm going to define two variable, that is stack. So here this is our empty stack, and here self dot minimum stack. Okay, so this is our class already given by lead code, and this is the constructor. This is already given by lead code. Okay, so minimum stack to store the value. Okay, and here extra stack to store the current minimum at each level. Okay, so I have two variable there that we can store the minimum values. Okay, so main stack to store the values, this one, and this is used for store the current minimum at each level. Okay, this is just store, this one it's going to store the values, and this is used for store the minimum value at the each level. Okay, so this is used for push means we are going to add values in integer. Okay, and output is none. So here if min stack is empty, okay, or if you are going to like take new value that is less than equals to current minimum, then here self dot stack. Okay, self dot stack, I'm going to append value. Okay, and here, oh, not it. Okay, so here this one is here self, I'm going to append self dot stack dot append the value. Okay, and if you have minimum stack is empty, then you have new value that is less than equals to current minimum, then here I'm going to write if not self dot stack, if not self dot stack, if not self dot minimum stack. Okay, so this one I'm going to copy from here and paste it here, minimum stack. Then if not self dot minimum stack, okay, it's mean minimum stack is empty. Okay, or value is less than equals to self dot minimum stack. Okay, so if you like if you have empty minimum stack or value that you want to add or you want to push that is less than equals to minimum stack. So what you have in top in minimum stack, okay, so like if value is less than equals to self dot minimum stack, if you are going to compare with top element, then I'm going to use this line self dot minimum stack. So here inside this minimum stack I'm going to append, I'm going to add values, okay, or you can say I'm going to push values, okay. So if you have empty minimum stack, okay, or value is less than equals to self dot minimum stack, okay, and here if this condition is true then you need to append by using append, or you need to push by using append. So inside this minimum stack you need to append the value by using append, or you need to push the value, okay. And after this here I'm going to define one other condition, that is else, okay. So push the same minimum again, okay, to keep the length same, okay. So here I'm going to use self dot minimum stack, okay. I'm going to append here what self dot minimum stack, this is self self self, oh, self dot minimum stack minus 1, push the same minimum again to keep the length same, okay. So here we are going to push, this is for push operations, okay. So here inside this I'm going to push the element, okay. So here this is our minimum stack, okay, this one minimum stack initially empty, okay, and stack is also empty. You can see here main stack to store the value, this is also empty, and minimum stack is also empty. That's one, okay. This is the class, this one, and this is the minimum stack equals to list, that is also empty, okay. So initialize both stack empty. Here I am going to push -2, okay. So here first of all I need to push it into a main, this one, okay. So here you can check push and value, that is 2 -2, okay. So here self dot stack I'm going to append -2 here in stack inside this, okay, inside this, and we are going to check these conditions. If not self dot min stack, okay, if you don't have any values inside this, or value that is less than is equals to sorry, if value is less than equals to self dot min stack, that is -1, okay. So here you can see now I am going to add -2 inside minimum stack also. First element is equals to minimum equals to -2, okay. So here I append both. So here self dot minimum stack I'm going to append self dot min stack -1, okay. This is for another condition. Now we are going to push 0, okay. So here value is 0, so first of all I need to append this in a main stack, this is the this one, okay. So self dot stack dot append I'm going to append 0 here, okay. Then we need to check minimum stack, okay. So here here we have elements inside the minimum stack, okay. So we are going to like this condition is false, okay. Like we can use this condition only when our minimum stack is empty, but we don't have any empty minimum stack because I already added -1 here, okay. So previously I added -1 -2 here, not -1, okay. And here I added -2 and 0, okay. So now I have -2 here, okay. So this condition is fail because I don't have any empty minimum stack, okay, and its value is less than equals to minimum stack minus 1. Okay, so we need to push them. So minimum stack self dot b, now this condition is fail. Okay, this one. Then we move here. Okay, self dot minimum stack, I'm going to append sam here minus 2 comma minus 2. Okay, so here minimum stack, I'm going to append minimum stack minus 1. Minus 1 means last element. Okay, so what is the last element in minimum stack? That is minus 2. So I'm going to append minus 2 again. Okay, so here it will become minus 2 minus 2. Minimum stay minus 2 and push them minimum. Okay, again I'm going to push minus 3. Okay, so here I'm going to push minus 3. So self dot stack append. So I'm going to append in stack minus 3 here. Okay, so here you can see here our stack will become minus 2, 0 and minus 3. Okay, now we are going to check conditions. Okay, here if not self dot minimum stack, okay, or value self dot minimum stack minus 1, okay, then it will give you minimum stack dot append value. Okay, so here I append after minus 2 minus 2 minus 3 new minimum find out. Okay, here minus 3. So this is our new minimum. So self dot minimum stack dot append minus 1. So here minus 3, minus 2 and here I will write minus 2 and minus 3. Okay, then after this you need to write code for pop. So here inside this pop I am going to write self dot stack dot pop. Okay, and here self dot min stack dot pop. I'm going to remove last element by using pop. Pop will remove last element from both. Okay, so self dot min stack and self dot stack. Okay, so it will remove last element. Okay, so this is pop function. Now I am going to write top. So here it will return self dot stack, and here I'm going to remove last element. Sorry, I'm going to write last element. Okay, so it will give you top element. Top element means last element. Okay, and get minimum, here to I want to return get minimum. Okay, so it will return self dot minimum stack. Okay, so here I want to get minimum element. Okay, so that is minus 3 from this. Okay guys, so if you want to use pop, then it will give you last element. Okay, and here if you want to use top, then it will give you last top element. I mean top element, that is also last element in a stack. So here and here, this is the object of minimum stack. Minimum stack, I'm going to use push to push the element minus 2, 0 and minus 3. Okay, so with the help of this minimum stack, this is the object and this is the function name get minimum, this one. Okay, and here I'm going to use pop, and here I'm going to use top, and here I'm going to use. So this is only for testing purpose. I'm going to delete this, and here I'm going to copy and paste it here. So I got -3. So minimum value is -3, and pop remove, it will remove -3 from here. Okay, and top value is 0, and get minimum, that is -2, new value. Okay guys, so I hope you got it. One thing, wait a minute. Wait a minute. So I already said that output should be null, 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 -3, null, 0, 2. Okay, so it is giving -3, 0, and -2. Okay, -3, 0, and -2. -2 get minimum. Okay, and top 0, and remove 3. This is the new minimum. Okay, so bye bye.